Hi everyone, good evening. The topic for today's technology forum discussion for me is AI-driven privacy engineering for post-uninstall data discovery and deletion. So what it exactly means is just to dive deeper into the problem statement. Over the course of a particular lifetime of end devices or systems that we use, maybe it mobiles or laptops, uh, personal computers, or even mainframe systems. Uh, in a personal capacity as well as professional capacity, we install a lot of applications. Of late, in the current environment, a lot of these applications use cloud computing, analytics platforms, and also AI ML in their background to process data and give relevant output. Given this heterogeneous environment and the plethora of applications that an individual uses, the data is stored or persisted in multiple diverse environments like logs where metadata could be stored, audit trails could be stored. There could be backups of the data that an individual is using in organization or personal capacity, cloud storage. Sometimes these applications connect to third parties, and even to some these third parties could be out of the geography where the organization or individual is residing. So overall, the entire, sorry, I think there is, so overall, the entire uh, application uh, in itself, the range of applications being installed is diverse, and adding to that, the data which is stored across various systems, that is also quite heterogeneous in nature. So once you uninstall that app, it does not generally guarantee that all the private, sensitive, or confidential data that is used, processed, or stored by the application is removed securely from all the environments that it had initially logged it. So that is where the privacy challenge comes into picture. So the key issues over here is a lot of personal data, which could be sensitive in nature. This could be your credit card information. This could be your personal health information, personal identifiable information, or for that matter, some sensitive data could also be left behind as residue even after you uninstall. So there is a stark difference between what the regulations say in particular geographies regarding how to deal with such sensitive confidential data and how it is practically implemented. So the overall approach or the goal of this particular research is to come up with a knowledge bank or a framework where privacy engineering could be automated and the entire discovery, classification, and deletion of this residual data could be managed in a proper way so as to strengthen the privacy of an individual at a personal capacity and also for organization which could have other data also like proprietary data, operationally sensitive data. I selected this topic because over the course of usage of multiple applications, realized a gap between how regulations um, formulate the workflows for deletion of private data and how it is actually implemented, the difference between letter and spirit. With the increasing use of AI, also a lot of training data, validation data, testing data is churned up, and that could also lead to a lot of private data being operationalized unknowingly. This all increases the privacy risk and hence needs a better management in an automated manner. So the whole goal is to have a framework where, first of all, you can discover this data, where all this is stored, and classify it. Not all data requires redaction, masking, secure deletion, or for that matter, scrubbing in from the entire source where it is saved, but only sensitive data. Some data could be public also. So tracking that and ensuring data deletion is what was the motivation for this research. And hence the research goals include securing the entire data lifecycle of an individual end device, identifying some good deletion technologies, um, analyzing privacy challenges because that also vary from individual to individual and region to region, and exploring a few uh, technology tools which could help in this regard. Some technology tools which were studied during the course of this research is first is cryptographic erasure. Although the concept is quite fundamental in nature and dates back also, it relies on the fundamentally it relies on the concept of, since the data could not be tracked and across diverse environments or storage systems or devices, it is better to encrypt it with good key length and good algorithms, strong algorithms, and eventually you remove the encryption key so that the encrypted data is inaccessible or could not be used uh, for any malicious intent. However, there are good technologies available which could support this cryptographic erasure. There could be keys for specific set of data. For example, confidential or sensitive data could have separate keys. Public data could have lesser stringent requirements of confidentiality. And technologies like Vault's, AWS's key management system, and HashiCorp Vault, Blanco, they provide additional features as well. The whole process could be automated. Keys could be rotated. The strength of the keys could be adjusted for additional strengthening of the encryption. Even to some extent, the secure deletion, that is deleting, putting garbage data, again deleting, so that no residue is left behind. All those things could be done so that the entire data is finally, once the app is uninstalled in an automated way, removed from all the environment which is available, where it is available. Another set of tools which were researched was for uh, privacy engineering of Gen AI and LLMs. So, as I discussed during the initial intro part, that many applications use AI and LLMs and ML for at the back end for generating output. It could be generative in nature, or it could be for uh, aspects related to chatbots or any other implementation of AI ML. But the fact is that they have a learning curve. So the AI ML models uh, create embeddings out of the natural data. So these are stored in vector databases. Then additional challenges or dynamics come into picture, because now these are additional data which is a representation of your actual data. So, and after that, then once it is operationalized, your interaction prompting, all those conversational memories also persist in the local memory as well as the backend or server side memory. So these create another dynamics. And finally, many of the organizational LLMs have retrieval augmented generation RAG, which is mostly used to narrow down the searches, avoid hallucination. So a RAG database also uh, increase the attack surface or the surface where the data is persisted. So all those things bring on additional dynamics, challenges towards privacy, which is usually sidelined during the course of operations or using the application. And sometimes customers don't even acknowledge that. So it is mostly sidelined. So having privacy engineering for Gen AI and LLMs is also very important given these additional dynamics. And technologies like Pinecone and VV8 provide these particular aspects where you can scrub the metadata, you can have additional access controls over the embeddings and vector databases, and they can isolate the environment where the LLMs are being used.
Stanley, you have 5 minutes to conclude the presentation.
Sure. The next two technologies that were analyzed was for AI-based threat hunting. And in this, it's more of how to triage the entire alert mechanism or threat intelligence mechanisms using AI and synthetic RAGs and LLM Cloud Hunter. The synthetic RAG is more user friendly with good platform workflow enablement, whereas LLM Cloud Hunter is more open source, customizable threat intelligence detector. So the entire workflow of identifying the alert, going through the logs, triaging, then response could be primarily automated and helps towards a better security operations. Finally, the last aspect towards privacy was not only protecting the data at rest and in transit, but during processing also. So Intel's trusted domain extensions, as well as AMD's secure encrypted virtualization and secure nested paging uh, technologies provide an isolated virtual environment where the individual CPU registers could also be encrypted so that the individual processing is encrypted and provides a trusted execution environments. So combining all these, the proposed future framework is to first of all acknowledge that after the deletion of the user app, the discovery of the data and its classification is as per the individual and organizational requirement, and then the secured residual data is also uh, removed. In conclusion, I would say privacy is quite important in the age, or modern age of AI, ML, and a plethora of applications that we use. And AI could help in this. And it also requires a legal shake hand because a lot of times the data resides in an environment which could be outside the legal jurisdiction. I'm open to questions.
Thank you, Stanley. Does anyone have any questions for Stanley? Okay, if no one have any questions, we would like to conclude our session for today. I'll stop.
Stanley, that was a very good presentation. Congratulations.
Thank you, Dr. Paul.